I'm very happy to be here today to talking about my project on parsing. And for the audience today, the presentation will be less technical but more about an introduction of the idea of the setup. And for those who were here last year, it will be more about some of the changes that have been made to the presentation that I did last year in Modular. So the presentation will, I try to make it more visual. So let me define what UMR parsing is. Let me show you what it is. So let's say we have a document of 2 sentences. And the job of UMR parsing is basically the same as the annotation process. We try to grab, we try to expose the underlying UMR structure from the natural language. And that is ultimately what we're after. It's just that instead of training the annotators to do this manually, we would like to have a model that can do this automatically. At this point, what is it for? We would like to establish baseline so that as models, as data set becomes larger and more models are made available, they can compare against the current version and see how much of the enhancement that they are getting. Also, we can look at the dataset properties. Is there some kind of a bias that we see in certain language, or is there a certain behavior that we see that's specific to one type of language as opposed to another language, things like that. And also, more practically during annotation, you can envision having the parser sort of give you an initial graph to start with, but then it does come with its own risk because it has been observed that in certain situations, for the annotators to instead of starting from scratch, if we give them the initial set of structure, then the burden falls on the annotator to first of all process the initial structure, and that for a complicated task like UMR annotation could prove to be more challenging than just starting from scratch. So that's where the actor is about. So for main considerations, for those who are new, it will be more about our pipeline setup, the motivation for it, why we chose this approach, as well as some of the insights that we have gained over the past year working on this project. And for those who are already familiar, it will be more about some of the upgrades that we have made to the setup from last year. So in theory, there are 2 possible methods of UMR parsing. One is, there can be multiple, but broadly speaking, we can come up with 2 different ways of categorizing these approaches. One is a fully end-to-end, fully joined model, and the other is a pipeline. So let me visualize what each of these are supposed to be about. Now, fully joined is exactly what I've already showed you in the very beginning. We have a document, and from the document, you're supposed to automatically get the entire structure in one step. So it's an end-to-end. But obviously, this is only for us humans to see, but for machines, for computers, it might make more sense for them to process this structure as a set of triplets. So essentially, the task of UMR parsing then becomes going from this document to this set of triplets. That's if the model can go directly from that to here, then we have an automatic, fully end-to-end UMR parsing. Now, the challenge with that is that UMR parsing is a difficult task. As I think those who have done annotation can really sort of get at this because first of all, you have the sentence level annotation, but then you have to group them all together, and then you have to think about adding the document level annotations like temporal and modal and corrections. So to do that in one step is challenging for the annotators, and also is equally challenging for the automatic approach. And that's made more complicated by the fact that this kind of difficult task doesn't really have that many annotations so far. So a more practical alternative to that is where our pipeline setup comes in. So let me sort of dissect each slide one by one. So instead of going right from the document to the entire set of relations, set of triples, we first do, so let me go from, so we have two sentences here. For the visualization purposes, I'm going to just focus on the first sentence. So let's see it being parsed on the left-hand side into a corresponding AMR graph. Now this is not UMR yet, this is AMR graph, and I just used some off-the-shelf AMR parser to get to this for this sentence. But remember, we had a document of two sentences. This is only for the first sentence. Now, only because of limited space, the second sentence is not shown, but you have to assume that behind the scenes, there's a second AMR graph that corresponds to the second sentence. Now, what's going on the right-hand side? This is where we come up with the document level relations. You can see on the red edges over these tokens, those are modal triples. Like you have the author to affirmative and negative. Oh, and by the way, I'm assuming that everyone is somewhat familiar with the UMR guidelines and definitions. And at the very bottom of this figure is the temporal edges, like before and after. But also, just below these tokens, you have the preference clusters. Like you have Kim and she falling into the same cluster, preference 1, and others and they falling into cluster number 2. So these relations are not at the sentence level, but at the document level, right? Now what happened is that, as I emphasized, the graph on the left-hand side was at that point AMR. It was not UMR. And even at the sentence level graph, although they do share similarities, we do have to make some conversion from the AMR to the UMR sentence level graph. And that's where you see the transformation from that to that. A lot of the predicates typically get inherited as they are, but you can see the aspect relation that wasn't there in AMR being added. Right? There was no aspect performance there, but you can see that being added here. You can see plural being added. So the graph has become somewhat of a different kind of a beast from what we started out with. Now what happened here is that now we are sort of ready to combine everything that we have. So at this point, what we have is on the left-hand side, a sentence level UMR graph. On the right-hand side, we have document level relations. Now we have to put this all together. The core challenge here is that these relations are between tokens, between things like left and join for this after relation. But in here, at least for English, the product of the AMR parsing produces AMR graphs, but they don't actually naturally produce the alignments for a lot of them. So we actually don't know that the leave O2 at the very top, the root predicate, it should be the original source for that concept is left. Although we know as annotators, we know that if we were to analyze the text ourselves, but the machine doesn't know that. So we actually need to introduce some alignment. And that's where this yellow coloring effect is supposed to highlight. We need to ensure that the left corresponds in the sentence level UMR graph to leave O2. Now for Chinese, typical Chinese UMR parsers actually do produce this alignment by default. But for English, a lot of them don't. There's one that does, but a lot of them don't. So now, and only for the presentation purposes, I'm only highlighting the leave and left, but it should be obvious that things, the entities like Kim should be mapped to this person subgraph, and on and on. You can see the join shipping that to join a 4 and on and on. So only after you do this alignment, then you can goes in the middle condition. So only when you have made this alignment, then all these edges that would be left or leave to as participant can be inherited in the final UMR graph. Like so. So we can see how the level 2 is here. You had the before and after. But these were not at the sentence level. The document level, these are document level relations. And only if we were able to align the level 2 to the left can we make these after and before relations. So putting it all together, we start with the document. On the left-hand side, we have a sentence level graph. On the right-hand side, we have document level triples. And then there's some conversion, alignment, and then everything comes together into the final UMR graph. The question that you might be wondering is, okay, it's so complicated. How to pull this off? Why not just go for end-to-end? And that's where the core challenge that I talked about at the very beginning, which is that end-to-end is a more elegant solution, but at this point in time, the data set is not, at least in my view, data set is not sufficient to support that kind of fully end-to-end training yet, I don't know. Or at least that's my view. So that's why at this point in time, we came up with this kind of approach as an alternative to that end-to-end solution. So we take the input document, and on the left-hand side was that sentence level parsing and the conversion, and then the routes number 2, 3, and 4, those are the document level triples. And they all come together through the alignment to produce the final UMR graph. And the core advantage of going with this route is that it's basically to deal with the small number of data sets that we have. Because we don't need to train on any of the annotated data. And how we could pull this off is that each of these components are trained on some external annotated data set. So let's say for modal or temporal, there is, for English at least, another data set. It's not big, but there is one that consists of about 400 documents with the temporal dependencies, relations annotated. So that model is actually trained on that data set, not on the UMR annotations. And we are bringing that trained model over there onto the UMR parsing. So that's why we actually don't need any of the UMR training data. But obviously, there are some catches. One is that it cannot be assumed that for all languages that you have access to these external data sets. And also, because inherently this approach is pipeline, where output of one model is fed into as input to another model, the entire model is prone to error propagation. So meaning, if early in the stage you make an error over here, that will be carried over to the entire rest of the process. So from this point on, it will be more about some of the details about each of the aspects, but I'll try to keep it short. So the AMR to UMR sentence conversion has been fully heuristics based, but there is work by Claire where she tried to use a hybrid approach of rule-based and training a neural network. And her focus there is not is especially on the split roles, where one relation edge label in AMR could become in certain situations UMR label A, or in certain situations some other label, or vice versa. So that's where you could train some neural network to help you with the conversion. So from now on, the results are going to be on the version 1.0. As some of you know, there is 2.0, but we're going to keep it to the official results, and the official results are only on 1.0 at this point. So yeah, the current batch performance that we get is an ensemble of 4 different models. Yeah. And document level relations are, again, there are 3 types. One is, let me start with the coreference. Below these tokens, you can see the preference clusters. Yeah?
Sorry, can I ask a question on the previous slide?
Yeah.
The results are for the sentence and document level together? Or does it seem like it's...
This is only for the sentence.
Okay.
The document will come later, and I think more results, Haibo will actually sort of show you in this part.
Okay, so this is for the sentence level.
This is only for the sentence level. So meaning, remember the pipeline, the slides that I showed you, this is only on the left-hand side output. So after you do the UMR parsing plus conversion.
So and this is only on English, right? For this table, it's only on English?
Oh, this is only on English. This is only on English, yes. Yeah. Thanks for the clarification, yes. So document level relations, there are 2 types. One is coreference, and the other 2 are modal and temporal dependencies. So coreference is something that is where I have made list changes to. There are 2 types of coreference. One is entity, the other is event. For entity, I do use this off-the-shelf coreference. Now, event coreference is a bit more nuanced, I think. There are more subtle elements to document level event coreference. And there is a model out there that I have been using, but recently I've actually been trying with just few-shot LLM-based event coreference, and that has actually taken to be the current version that I'm currently using. But the thing about coreference is that the current version of the UMR parser, or the pipeline model that I have, is not able to predict subset of relation. It can only do same entity or same event. It cannot do subset of. And this is where there's a recent work by Chun, where she has focused on the event level coreference and decontextualization. I think with that new data set, this part could be more looked into, but at this point in time, we are not able to predict subset of relation for coreference. Now for the model, I think for the UMR parsing results, we do tend to see that the model results are typically higher compared to temporal or coreference, and that's because for a lot of the conceivers and events, their head is actually just the author. So having one single dominant candidate can help you out, especially for complicated tasks like parsing. So, and a lot of times it will be affirmative to the author. That's why the modal dependency parsing tends to score higher compared to other tasks. Now, temporal is slightly more difficult. I will only mention that for temporal, there's a slight difference in how temporal dependencies. I shouldn't say difference, but there's a slight nuance to how the temporal dependencies in the UMRs are annotated versus how they are annotated in the training data set that I'm using. So in that data set, it is always assumed that event only can have 2 heads. One to another time expression to another event. That may not be true for UMR type of annotations, and it's made more complicated by the fact that if an event participates in a preference cluster and earlier mentioned has its own temporal relations, the dimensions that follow may not actually give you any kind of temporal edges. But because our model is completely pipeline and modular, where the modal and temporal where temporal models and modal models do not communicate with each other, that's not something that we can model. So there are certain clear inherent limitations to this approach. Now alignment is also where there's not much for me to say about alignment. It's just that we need to have a good alignment for this entire thing to work. It's just that alignment is a very, compared to AMR parsing or modal parsing, it's even smaller topic than that. So we do end up having to use some of the outdated, some of the old packages, and I think this is also another point where we could try to sort of integrate more reasoning LLMs to try to outdo the current alignment performance. But yeah, what this diagram is showing is that in order for these two affirmative and negative edges to be displayed over there, we needed to have leave O2 and join O4 aligned correctly. I believe I have about 30 minutes, so let me try to go through that really quick. Okay. So in addition to the English results, we do have Chinese results, but I'm going to let Haibo show that because evaluation is more for this project. Now, a quick note about the Chinese parsing is that, the Chinese AMR parser does produce the alignment automatically, so that's one less room for another separate model. But for Chinese, there is no gold reference data sets for TDP. So the performance that you will see, the results that you will see in Haibo's slide will have 0 for temporal events in best state. But we are working to fix that. I'll get to that more later. So so far, and also it's also true in Haibo's results. The results so far are only on English 1.0. But as some of you know, there is a release of 2.0, and these are some of the updates that have been made to the release. So for Chinese, it went from 7 to 26. There's a lot of check. And for English, we have gone from 5 to 580. Now, some of them are missing the document level annotations. So that needs to be taken into account. But I guess the data set is becoming larger as time goes. So here is where, for those who were in Boulder last year, essentially the original column is where it's a setup that I described in the paper as well as in the presentation at that time. It was a four-array ensemble AR parser, heuristics-based conversion, jammer plus ISI alignment, reference model, event reference. So you can see there's a bunch of models that has been used. In the current version, we have actually moved to replace some of them with some of the newer techniques that we have. So for example, for conversion, we are trying to incorporate Claire's machine learning-based approach. For alignment, we are exploring the LLM-based approach as well as the reference or event reference. For modal and temporal, we are actually using our very own model. So these are actually our own models. For Chinese, that's the AMR parser. Now, Claire's hybrid approach actually is only for English. So for Chinese, it has to be currently only heuristics based. There's no need for alignment. And for Chinese, I actually had a hard time finding a good reference. So at this point in time, they are all LLM based. And my model for modal and temporal is to be carried over to the Chinese. It's just that for TDP for Chinese, as I said, there is no data set. So how we obtain the results here is we take the English data sets, English annotations for TDP, and we translate using the LLM into Chinese while maintaining the edges and hints. At this point in time, I think that's probably the best that we can do when there's no gold reference annotation. So, and by LLM based, I just mean that it's at this point in time, it's a closed source existing model in a few shot into setting. So this is the slide that I used last year for future work. We do have results on Chinese UMR parsing, but it is without TDP. So only when we can use TDP will this be complete. Enhanced modal and temporal parsing. We are working on that right now. Actually, we do have a model for modal, and we are currently working on temporal. That's actually my current focus right now. And number 3 and 4 sort of they're more about if we had more data, we could fine tune the model. Let's say like temporal on the subset of UMR data set if there were annotations. And it seems like more data is being made available, so it is becoming plausible, but because a lot of them are at the sentence level, for document level relations, I'm not very sure, but for sentence level, the number of data points that we have right now in 2.0 is promising. Now, are we ready for the end-to-end fully joined training? I don't think so at this point. That's my view. So that's why you can see the log icon, but we'll see how it goes. Now, in addition, at this point, we do need to evaluate the model on 2.0. That's because 1.0 only contained like 5 to 8 documents, and the performance on that small data set cannot be taken as reliable results. So we do need to evaluate on the version 2.0. It's just that 2.0, it seems like some of them are missing the dependency relations, so that needs to be taken into account. And also, one theme across this page is that previously we had all sorts of different models, and now I'm trying to consolidate into fewer models that share the source code base, so that as a user and as a developer, you can have a more easier time installing and trying this thing out. Because previously, when you had these multiple things going on, especially with the aligner sort of relying on the outdated packages, I'm pretty sure I was probably the only one who could actually run it. But we are trying to move to a more consolidated setup, so that different people can have easier time trying these out. So that is where I get to stop, and before I leave it off to Haibo for his work on evaluation on the UMR parsing. I mean, I've had some questions along the way, so thanks for the clarifications. But if you have any at this point, I can briefly take them before I hand it over. Yeah.
I'm just trying to understand. As I understand that this UMR kind of representation is always capturing information, representing information of different kinds. And each of these kind is actually a tool or software by itself. Like for example, co-referencing itself is an independent task, parsing is an independent task, discourse connective marking if you are doing, that is also an independent task. So, and people all over the world will be working on improving this system independently. So in our architecture of UMR or this kind of design, where we are actually putting different tools together, so I think we can have one feature where it is always a plug-in, plug-out mode. Like if tomorrow you get a better parser, open source, or maybe in your lab 2 different people have designed and developed, you would like to have the better one for the whole architecture purpose, right? So if we make it pipeline, I'm just wondering, if we make it a pipeline architecture, then your freedom becomes lesser than if it is a kind of blackboard approach, or where it is a plug-in, plug-out approach. All things are there. You are seeing, I'm just imagining,
Right.
You are seeing the outputs, and if something is doing better, so you have a method of regular evaluating different independent tools, and as and when you are getting a better, you just plug in it. And when the output is coming from different sources, from different tools, you are also doing some heuristics, right, to design your final UMR. For example, I was just thinking like if I have a discourse tool and a parser, and all my words are indexed, right? That index itself gives me alignment. See, my words in the sentence are fixed. And if I index them, I am running a parser and I am running a discourse, whatever tool, the same from the index of the word itself, I know what would be the alignment.
Right. So there are multiple parts to your question. So let me address the first one, which is the fact that, and you are essentially getting at the heart of this approach, which is a modular setup. And the reason why some of the advantages of the modular setup is that you can optimize subcomponents individually. And for a well-defined task like reference, as you've mentioned, there are other people working on it because there's a conventionally accepted data sets such as ECB plus that people are trying to optimize against. And the performance there is actually pretty good already. Now, supporting the plug and play is a software problem. It is definitely a meaningful implementation, I think. I think it makes total sense. It's just that I think we are trying to get to a place, but I mean, you cannot. The support for that does have to sort of come with their own support, meaning we do need to know which models you are trying to experiment with because different models have different input expectation and output format. So that in itself doesn't actually make plug and play entirely just automatic thing, but it does require some careful designing. But I think that is what we're going after. That idea is what we're going after.
Pipeline approach, you said input-output structure, you are sort of somewhere dictating the input-output structure. But if you kind of take, and it will happen, tools will be coming from different sources, you cannot really dictate the input-output structure.
Right. So that's where we have to come in to manually define that kind or modify so that everything comes together as a single piece. But yes. And also the last point, let me think. So the last point was about, do you remember what the last question was about?
So many questions.
What was the last question about? I'm addressing the first time. Or,
So maybe forget, maybe that is not it. I always say that to my daughter. If you're forgetting, then that's fine.
because I think that was also getting at the heart of the core idea as well. Yeah.
So maybe I can just add a few things there. So in theory, that's a good idea, right? So you have all these different components, and you can train them separately, and you can put them together through alignment to the text. There are a couple of things that make that currently at least not that straightforward. One is that the individual components, the data set they're trained on, are usually span-based. Their categories may not be exactly the same as what we have here. So you have to make some sort of adaptations if possible. So you're going to lose some information here. So for reference, so UMR has basically analytic reference. Two things are the same, or a subset. So one thing is the subset of another. But in some other data sets, they might just have analytic reference, right? So that cannot be, it does not have enough information for this. The same thing for the temporal annotation and for the modal annotation. We don't be slightly different, right? So you kind of, in general, that's possible if there's coordination between people who work on those data sets and UMR. But in practice, there are always some different. The other thing I want to notice is that there's a lot in UMR. There's a lot of abstract concepts, Most of the data sets are text-based, right? They're not text spans. So this span of text and that span of text, together there's discorrelation between them. But UMR infers some things that are missing from the text. So that part of it is also something that cannot be getting at very easily. So there's some practical challenges to this. But in general, there's better coordination between the different projects. I think that's possible.
So to go, I figured out what the question was, and you mentioned that for, or at least in your setup, you had an index-based tokens, and as Bert mentioned, we do deal with spans of text, but then at the same time, the spans could be perceived as span of indices. Just that the alignment that we're talking about here is from the token, let's say the left, which has an index of let's say 2. Or 1 if it's zero base, to the concept. And that alignment it cannot be produced automatically for some languages. So the alignment there does require a separate model for English. So you need to know that the triples that you see over here are between the textual tokens or spans. But in order to make them, but that's not. Let's say you have this after, let's talk about this here. The left to join, this one. Now, textually we know that there's the temporal edge from left to join. So if, as humans, we see this corresponding graph, we know that leave or 2 correspond to left, and join of 4 corresponds to join. But the model doesn't know it. So the alignment that we're talking about is establishing that join of 4 is that join and not some other join, and leave of 2 is the left. Does that answer your question, any chance? Yeah, there are a lot of moving parts. There's a lot of moving parts, and yeah, so if I don't have any more questions, I will hand it over to Michael. Okay.